This is Mr. Herman here. The topic of this video is going to be systems of linear equations. So a system of linear equations is when you try to solve two or more linear equations at the same time. We're going to study this by graphing, and so we'll take a look at our definition of solving a system on a graph. That's going to be when the two lines intersect. Okay, so intersect, that means when the two lines cross each other. And we'll look at some pictures, look at some graphs of what that looks like. But since we've talked about function notation, we do need to know what function notation will look like if we're solving a system. And so if we have two functions, f of x and g of x, those two functions will be equal. Okay, so if those are equal, then we have a solution to a system of equations. So let's go and take a look at a graph to help us kind of visualize what's going on here. So we're going to identify the solution of the system of linear equations here. So we just said that the definition is when we have two lines, two or more, and they intersect. So we've got our equation for y equals 2x minus 1 here in blue. We have y equals 1/2 x plus 2 in red, and those are already graphed for us on the graph here. And we just got to figure out what point we intersect at. Okay, so it's maybe not perfect in this case, but that's going to be this point right here. Okay, and so if we look over here, we go in 1, 2 to the right, and then 1, 2, 3 up. So our solution to the system is 2, 3. Okay, that point right there, because that's where our two lines intersect. So essentially when we're solving system, we're looking for where do our lines intersect, and that's our solution. So let's go ahead and do some graphing. Okay, we spend a lot of time graphing lines in class, and so we're going to graph a few more. And so let's start with our top graph here, our top line. That is in slope-intercept form. We'll have that in blue here. So if I'm pulling my slope out of here, we have m equals 1. I like to put it as a fraction of 1 over 1. And then b equals -2. Okay, so m is the number in front of x. B is the number by itself, since we are in the y equals mx plus b format. Okay, m is in front of x, which is 1, plus b is the -2. So let's go and graph that here. We'll start with our y-intercept, so b is -2. And then our slope tells us to go up 1 and over 1. So up 1 and then right 1, because we're positive here. So we go up 1, right 1. I'll just do it again. Up 1, right 1. Okay, so there we go. We got our first line here in blue. So that's the line of y equals x minus 2. All right, now we have a second line here that we'll do in red, x plus 3y equals 6. Now with this line, we are in something we call standard form. And we'll talk more about this in our remediation tomorrow. But with standard form, since we don't have y by itself, we're going to go ahead and check our intercepts. So what that means is we're going to say, let's check two things. When x equals 0, we'll solve the equation. And then when y equals 0, we'll solve the equation. So if x equals 0, I'll say 0 plus 3y equals 6. And then that 0 is going to go away. I have 3y equals 6. We want to get y by itself, so we'll go ahead and divide by 3. 6 divided by 3 gives us 2. So we have the point 0, 2. So I'll go ahead and graph that here. So 0 and then up 2. All right. Now let's try when y equals 0. So we have x plus 3 times 0 equals 6. 3 times 0 is going to give us 0. So x equals 6. So our next point is 6, 0. So 1, 2, 3, 4, 5, 6. How convenient. Let's go ahead and draw a straight line there. Okay. So we've now graphed our two lines. And since the graph's not perfect, we're going to have to estimate what that ordered pair is, but we know that the solution of a system is where two lines intersect, so it's going to be right here. Okay. And let's see. That's going to be 1, 2, 3, and then up 1. So that point is 3, 1. Okay. So once again, our solution to our system is where the two lines intersect. Okay. So let's take a look at another problem. This one is in context here. We got a word problem going on. So we got Dr. Holdren. She's buying lunch for the freshman teacher. She's got to buy 15 sandwiches. Chicken sandwiches are going to cost $4 each. Okay. So $4 each. Oh, wrong one. And roast beef sandwiches are going to cost $5 each. She can spend $70. How many of each sandwich should she buy? Now, we're going to have to write a couple equations here, and then we'll graph them. So let's start off with our sandwiches. We know that she has to buy 15 sandwiches. She can buy either chicken sandwiches or roast beef sandwiches. So let's say that chicken sandwiches are X. Roast beef sandwiches are Y. So she's got to buy X chicken sandwiches and Y roast beef sandwiches for a total of 15 sandwiches. Okay. Now, in red, go ahead and underline this in red. Okay. What do we know about our sandwiches? We know that the chicken sandwiches cost $4 each. Remember when we were writing equations, so each means it's going to go with a variable. So we have 4x, and roast beef sandwiches cost $5 each. So that goes with a variable. So 5y. And how much money can she spend? So if we have $4 times the number of chicken sandwiches, $5 times the number of roast beef sandwiches, that's $70. Okay, so we have to graph these equations. Now, let's go ahead and graph them. So I'm going to go ahead and make a graph here. And we'll have to do a little bit of work with this with our labels. But since we're in standard form, I'm going to do this for one of them is I'm going to rearrange. So what's in green, we have x plus y equals 15. So I want to get y by itself. Now 15 and negative and minus x, are those like terms? They're not, since this one does not have a variable in it, so we have to keep those just by themselves, so 15 minus x. Now with what's in green, I have a slope of m equals negative 1 over 1, and my b, the number by itself, is 15. Okay, so we'll go ahead and graph this line. All right, so we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. So our y-intercept is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. And we're going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Down 1, right 1, down 1, right 1. Okay, so then we have our green line. And then with red, we'll do our intercepts. So we have at x equals 0. So we've now got y by itself. Okay, so we have x 0, y is 14. And then we've got our other one here. So we have x equals 0. We want to say that y equals 0. Let's see. Okay, y equals 0. 4x equals 70. Divide by 4, divide by 4, x equals, is that 17.5. So 17.5, comma 0. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. Then we'll go ahead and draw our lines. All right, so then our final point where they're equal is somewhere in this ballpark. Okay, and so let's see. 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8. And 1, 2, 3. Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to put it here. Maybe 10 on the x-axis. And then 1, 2, 3, 4, 5 on the y-axis. We'll put that there. Okay. So 10, comma 5 is where I have them as being equal. Because our x-axis is measuring the chicken, and the y-axis is measuring the roast beef. All right, so that is systems of equations.